Well, this is going to be a boring technical talk, so I thought that I should probably introduce myself in a little bit more details. I remember one day when NGINX has not yet existed as a company, and I met with Igor, and we were joking, and I said to him, "Hey Igor, one day when you'll start a company, don't forget to call me and offer the job." So he did. I entered the company early in 2011, and my first project was to translate the entire documentation into English. It lasted for more than a year. Amongst other things I was doing with NGINX, with open source, I have been written and adding support for IPv6 throughout the entire NGINX modules, while generally fixing bugs but also adding new ones. And when we started NGINX Plus, I worked closely on tasks such as dynamic configuration of upstreams, health checks for them. I was also reviewing Valentine's code for speeding HTTP2. Besides NGINX, I'm having quite a big family. I live with my wife and 4 daughters. They range from 1 year to 16 years, so I'm supposed to know how to balance. But to say the truth, I must admit that balancing using NGINX is much easier than it is with real people. So let's start. My name is Ruslan, but I don't mind if you call me Ruslan. And I am a developer for NGINX. In this talk, I'm going to describe what we are doing in the still ongoing project that will eventually add support for dynamically loadable modules into NGINX. Since its public launch, NGINX had a notion of modules. Its first public version, which is 0.1.0, which was released in October 2004, already had over 30 modules, including 22 HTTP modules and 5 core and 9 event modules. And today, after a decade of continuous development, the current version, which is 1.9.5, which we released 2 days ago and seriously encourage you to try, has almost 100 modules. It has 97 modules. So let's look under the hood. Core modules. They implement basic things such as generic types and objects. There's numbers, strings, arrays, lists, hashes, buffers, queues, and trees. They also provide memory management API. We have pool allocator, shared memory with slab allocator, lock-in primitive for them, such as mute access, spin locks, read-write locks, almost the entire operating system. It implements several checksumming and hashing algorithms, configuration file parsing, and configuration management interfaces. Login, including syslog support, timekeeping, asynchronous resolver, connection management. The core modules also responsible for OS-specific tasks such as file and socket I/O, process management, IPC, timers, CPU affinity, and later thread pools for offloading blocking I/O operations. The event modules are responsible for connection processing. They implement such things such as epoll support on Linux, KQ on BSD-like systems, devpoll on older Solaris and some other Unix derivatives, event port on Solaris 10 and later, and archaic methods such as select and poll. NGINX will automatically choose the most efficient method available for the platform. HTTP modules. Well, it is what makes NGINX a good web server. And as you may have heard already, NGINX is now the most used web server among the top 100 key web servers in the world. New to 1.9.0 release, we have added a set of stream modules, and they brought us to the market of generic TCP proxy servers. Mail modules that existed for a long time and were used at Rambler. The company Igor started writing NGINX at. It allows for proxying IMAP, POP3, SMTP using NGINX. More modules. Over the years, the growing NGINX community has developed over 10,000 of modules. Please applaud. We know quite a few companies that write their own modules for NGINX. And last but not least, our commercial product NGINX Plus adds another dozen of modules. Among them are modules for media streaming. These are HLS and HDS, modules that implement session login instead of just simple access login available in open source version. We have extended monitoring and status that allows to look through entire NGINX. We have upstream dynamic configuration and health checks for them. We have also implemented additional balancing methods such as NTLM and list time balancers. We also have request thickness to backends, to name a few. NGINX Plus also extends a lot in existing modules, like cache purge support, limiting the maximum number of connections to upstream servers, or keeping upstream configurations up to date by tracking DNS changes. So how it all works together? The set of modules that constitute an NGINX binary is currently fixed at compile time by the configure script. Standard modules are added or excluded to the list with and without module options, which are shown on the script on the screen as example. Though the ability to compile in external modules appeared in the early version of NGINX, the demand on dynamic module loading was low. The number of external modules was pretty moderate, and to be honest, implementing support for dynamic loading wasn't a high priority task for Igor. I interviewed him specifically before giving a talk. Nevertheless, it was considered. DLL Open allows you to easily load dynamically as a piece of code into any binary. But while a DLL Open is a mature system interface available for a long time in almost every modern Unix-like operating system, the dynamic loading can open a can of worms, cumulatively known as Dependency Hell. Some call it DLL Hell. One of the typical problems with dynamic loading is when two modules are linked against the same version, against different versions of the same library. If this happens, this can manifest itself in random crashes or other hard-to-diagnose problems. So what NGINX offers now? One of the little-known features that NGINX offers allows you to upgrade its executable on the fly. Here is a link on the screen to our site which documents this in detail. Using this feature, it's possible to run another NGINX binary that was built with a different set of modules that you need, yet without the interruption in service. So you can just tell NGINX to upgrade the binary, providing the new one, and it will switch to a new process, and yet the old process will handle all connections until they complete. It works well when you have sources for NGINX and sources of all modules that you need, and have a freedom of mixing them in a way you need it. Unfortunately, this is not always an option. Vendors ship NGINX in binary packages, I mean Linux vendors, and they usually provide several of them, each with its own set of modules. For example, on Ubuntu 14.04, there are 5 base packages of NGINX. These are NGINX Core, NGINX Lite, NGINX Full, Extras, and NGINX Nexus. NGINX Plus also comes with several packages. But what if you're not happy with the set of modules? You don't have the flexibility to just add another module to the crew. You have to recompile NGINX. This means basically that you can't use the provided packages. And as the number of third-party modules grew, and especially with the launch of NGINX Plus in August 2013, it became obvious that we should invest some time and allow modules to be loaded dynamically without the need of recompiling NGINX. Because if we do this, this has a potential of reducing the number of packages that vendors should ship, because individual modules, you see, can be shipped as distinct packages in addition to only one base package. If you look at NGINX Plus, it is partly closed source, so you just can't recompile it with a custom set of modules. If we support dynamic loading, we may allow certain modules that pass our integrity checks to be loaded along with NGINX Plus. And like I mentioned earlier, there are also a growing demand from other companies that are interested in either being able to be running NGINX Plus with their own modules, or just to be able to supply their binary modules against the open source version of NGINX. Well, when it came to implementing, the working prototype was written in 2 hours. It could load the empty GIF and GeoIP modules dynamically. The traces of this attempt are shown on the screen. If you are familiar with Unix, in this case it is a FreeBSD, it shows you on the screen how different binary objects are loaded in what order. When it comes to building, the syntax for building dynamic modules just extends the existing syntax. Basically, you tell that you want to build some modules dynamically, and the rest is supposed to be handled by the configure scripts. They generate the necessary makefile rules to build NGINX and the requested modules. For example, if you build the dynamic GeoIP module, the dependency on the GeoIP library shifts from the primary NGINX binary to the module. The module then can be packaged and distributed separately. That's one of the reasons we don't put modules, our own modules that have some external dependencies into the base package. So we'd like to avoid unnecessary dependencies on other vendors, other repositories, and so on. Or it could constitute for some it could constitute some legal issues because of, different licensing. Building an external module dynamically is not much different. There is only a slight change to the existing syntax. Well, I will talk more about external modules a bit later. For the configuration file, we added a new directive, load module. It tells NGINX to load a module at program startup. Once NGINX is running, you can change the list of modules by simply editing the configuration file, adding or removing the necessary load module directives, and then, when you're happy with your configuration, you can signal NGINX to reload its configuration as you do today. NGINX will check the syntax validity and try to apply the new configuration. If this fails for some reason, NGINX rollbacks changes and continues to work with the old configuration. If in between of changing the configuration, the set of modules has changed in such a way that some modules became unused, they will be unloaded after applying a new configuration. So let's talk a bit more about implementation details. Some modules have interdependencies that should be taken into account. For example, if we take three so-called index modules, these are standard modules, they are random index, just index, and auto index. They should be loaded in this particular order, or they won't be able to run as planned. The same holds true for the chains of filter modules, if you are familiar with NGINX internals. So, the point is there are interdependencies and they should be somehow taken into account when we load the modules dynamically. Not all modules can be made dynamic. There are some modules, among them are core modules, that are an integral part of NGINX, which can be cut into loadable objects. There are also some complex modules. For example, the mail is actually a set of several modules, but they're written in such a way that makes it impossible to cut specific modules. So now, mail is a single loadable module that provides 8 NGINX modules. The same thing about complex modules is also true for some complex external modules like RTMP and Lua, which are quite popular. Well, another problem with NGINX one is that it doesn't have a cleanly separated programming API. In contrast to libraries, when you program for NGINX, you basically should muck with its internal structures, call its functions, and sometimes even you would like to make some static functions to be external. So internally in our group, in our small group of developers, we often not sure is it a part of API or not. NGINX also doesn't provide some abstraction layer like some other programs do that can be used by external modules. So when you program an external module, it is not different as much as you're just extending NGINX with some other module. So what the problem is this? NGINX has a lot of conditional compilation defines that may influence the sizes and contents of various structures. And this also has to be taken into account when building a custom module. That is, to build a module not as part of NGINX build, when you already have a binary and just want to build another module for it. You have to use not only the same version of NGINX header files, but also the same set of compilation defines, at least. There are also some corner cases, like what to do when a new configuration removes some filter module, but we have to roll back to previous configuration due to some issues. Internally, the filter modules are organized as chains, and in this case, we would have to restore the filter chain to its previous state as well. This is one of the tasks that is still not solved. So what it all means for module developers. If you are not interested in dynamically loading your module, you don't have to worry. everything will continue to work as before, and you are not required to modify the sources of your module. If you do, however, you'll be required to make some simple changes to your module's configuration file. An example on the screen shows how such a config may look like. It's still under the works, but this is a working prototype. Basically, you specify the type and name of your module, supply the list of header files and an optional path to them, the list of source files, and libraries the module depends on, if any. Everything like before, but in a slightly different format. The new auto module script will handle the rest. It will either generate makefile rules to build the module statically or dynamically, as you have requested. More complex modules may require more changes to its configuration files and maybe multiple calls to the auto module script. So, who is in charge of this project? There are 2 developers involved in the project, and you can see their names on the screen, and I am one of them. We expect to finish and commit the whole work by the end of this year. It is split into several stages internally, so we'll probably publish some intermediate results earlier. The first thing we would like to achieve is to be able to ship the only one base version of the NGINX Plus package, and then other modules that extend it. And in the end, you will also be able to allow external module developers to build their modules without having NGINX sources. So you could just take the package, use some bits from it, and build your own module and supply it as a package as well. So the commitment is end of the year. Well, thank you. And we now have plenty of time for questions. Or maybe if you've got more questions, not about dynamic modules, but for other topics I mentioned, either it is about open source or about NGINX Plus, I welcome you to the Ask NGINX Experts booth, which I will be on duty today starting at 2 p.m. So, questions? Thank you. Yes? Sorry, noisy.
Unit and integration testing for dynamic modules. So what would be your recommendation for dynamic module developers? How to go about it?
This doesn't have any straight relation to dynamics nature, because if you're careful about your module, currently external modules also allow you some. It's per developer. So we have a set of tests. It would be nice if you could try your module with a test, with our own test suite. You can put your own test for your own module and ship it with your sources. This is all how things already work.
So you'll have to create some kind of fixture to load your modules. Not out of the box. Something you that.
No, it's not out of the box, but like I said, we provide a set of. It's not about dynamics. So you just write this. When you test some module, it looks like you're writing some configuration that utilizes your module, and then run NGINX with this module. And this is not different with dynamic loading. You just need to put the one directive which will load your module into your test. So, I mean, module developers are responsible for supplying tests for their own modules.
Okay, thank you.
Any other questions? Yes, please.
You mentioned that you'd be able to build plugins without the source. Does that mean that by the end of the year there'll be a published API with header files we can build against?
Can you say it again?
Yeah.
Closer.
You mentioned that the dynamic loading will let you build plugins without the source by the end of the year. Does that mean there'll be a published API with header files to build against?
Are you asking if we already have something to...
So,
Andrew, can you help me, please? That was on my last slide. I told it's still ongoing project. So we don't have any ready for public code yet. We are still Was that me? We are still experimenting, and no code yet. End of the year.
Maybe it's more, it's going to be possible to compile modules outside of databases.
Yeah, I already told about this, just not without some slide. The most demand is to be able to build external modules, obviously, and that will also be available by the end of the year. No questions? Everything is clear? Everyone is happy? Okay, thank you.